This presentation is entitled Teaching Using the ONSBlue Approach. Something old, something new, something borrowed, something blue. This approach is trying to look at, investigate the old approach of using the blackboard and chalk approach to teaching, and the new approach, which is using 21st century skills, which relies upon technology and the usage of digital native students who are basically grew up in a digital world. Can they relate to the old world of using blackboard and chalk? This old approach spent a lot of time with the lecturer, had to impart knowledge to students. As opposed to the new students of this era, we have students have easy access to information, so imparting of knowledge is not necessarily a heavy focus. What is more a focus is illustrating how this knowledge is used or can be used. So this new approach is trying to see, can we use both approach? Why? Because the instructors are normally of the old regime because they were taught using blackboard approach, and then students require the new regime, which is using technology. What can we do to help bridge or make these two worlds meet? What we are saying is that we would like the students who has information to pull together. That's a driving force. To collaborate, to encourage thinking, to motivate them to open up and share what it is they know so that we can build on what it is they know. We can create problems, we can solve problems, we can help stimulate them to think about making new problems. So what the instructor is doing is actually guiding the ship of knowledge for students for learning. They are guiding them so that they can be able to take whatever knowledge they have and build upon it. So what we have to do is we have to pick an application which is very realistic. You demonstrate it using a projector and a computer. Then we will do the application on a board where the students has already seen and have already been motivated that this is going to work, and they can see need and use of it. And now we remove the projector and we now focus on the board, trying to see how much they have understood by what they have seen using technology. So we use the blackboard to actually create back the technology. So on the blackboard we have a monitor and we draw a CPU. And what we do is that we let the students be the CPU. So together they're going to decide what is going to happen in the CPU. So they are basically replacing technology with their own minds. So here's how it starts. This experiment was done using a programming course teaching you to use C++, assuming they knew nothing. And then it was demonstrated that the empty shell shows that the program works but does nothing. And then we run that, we run that for the students, and then we start building on the empty shell so that they can see how things evolve. On the board, we will also maintain the monitor and the CPU. So the easiest thing that a student knows is that something is given. You ask for something. So we ask for an integer. So we write that as input, process, and output. So you want to ask the user for input. So therefore they will use syntax, cout, enter number. Now, that's the normal process a student will think about. So what we do now is that we enter it. And then when they go to the board, they realize on the monitor, this is displayed to the user. So it comes out the exact way they typed it. Enter number. Right? Now, what you would observe is that there's no way to collect the number that the user has entered. And this is illustrated that when you run the program, the student realizes, yes, I have done well, I have told the user, enter number. Now, what was the number the user entered? You have no way of knowing it. So the student now realized that you need a container to collect what the users asked. So now they will prepare their container before asking the user. So instead they will say, they will prepare their container integer and they label it. We demonstrate how a container has to be labeled so that you will know where you put it. So now we have progressed. The user knows that you want a number and you have prepared a container to collect that number. So now the number is collected. So the user put 56. So you have actually hold this 56 and put it in your container. Now I ask the student, now show me the number. Show me the number. Now what you realize is that you have indeed taken the number and put it. But now you have to give it back. You have to show it. And that has to be an output. So what you have to do now is you have to actually put it into the container properly, which is Cin, and it goes into number. So at this point, here's where it goes into the number. So at this point, you know it's where you have put it. You have put it into the container called number. So now you have access to that container. Since you created a container, you have access to it. So you shall say cout number. And there you have a very simple program. So we move a step further and show the student then that you can process this, because so far you have only collected and output it. So the simplest case of processing is students are concerned with grades. So you use an if statement for decision, and you say if, and the number is what you have stored, which is your container. So you say if number is greater than 49, then the student has passed. So you will send a message and you will tell them pass. But before you reach on the board, this had to be run on the computer using the technology so that they can see it works, and then you're going to motivate them to be able to think about what is going on. Progressively building it up encourages students to think more, and especially if you show them at first, then it helps them to motivate them that they know it can be done and they do not be so afraid to share their thoughts. Now, if a student doesn't pass, they have to fail. A decision means either yes or no. So hence, you will spend some time later on showing them that the no part comes from the else, and you simply say cout fail. So you're actually trying to build a decision from scratch and very slowly. And afterwards, they will be able to say, but Miss, what if I got an A? How would I know I got an A? What will I got a B? So then you will take the past and you will take this category and you will say out of this category you want to get more details. But you leave it to students to think that. You motivate them to think and realize what it is they are doing, and they should be able to come up with that without you telling them that. This approach basically was tried with a class, and here is a graph that shows the results of the students. Now these students all did a prerequisite course, which is Introduction to C++ Programming, and this was another course which is an advanced course to C++ Programming. And what you have is the light color shows the grade of the students before they do this course, which is a prerequisite grade, and the darker color shows their grade at the end of this approach. What you realize is that the students have all done well. Actually, in this class, they had basically, everyone had an A except for 3 students had. So what I am proposing is just like a marriage, where 2 people come together so that they can have a better output and they can start a new family. I am actually suggesting that we could try the approach of taking the old blackboard chalk and marry it with the projector, which is technology, and we can have a wonderful output, because we can take the best of both worlds and we can create an atmosphere which is comfortable for the instructors and also comfortable for the